first thing that you need to remember that this is a rational function. Step one, right? What class of function it is. As you can see, right, we have given this function, but nowhere it is written that this is a rational function, right? But you can see that the numerator is a polynomial and the denominator of this function is also polynomial. Okay, x squared plus 5x minus 3x squared plus 5x minus 1, that's a quadratic polynomial. That's the numerator. And in the denominator also you have a quadratic polynomial, which is x squared minus 4. So it's a ratio of two polynomials, one in the numerator and one in the denominator. Okay, so we know that this is a rational function. Now once you know the rational function, then you need to remember all the important properties of the rational function. Okay, and the one thing is the definition of what is the asymptote of the rational function. And we will give you this formula, right? General idea in a little bit, but typically when we talk about asymptote of a rational function, there are three, depending upon the three conditions, there could be three possible definitions. Okay, now the general rule for rational function is you need to find out and compare the degrees of the numerator and of the denominator first. Okay, so when we talk about degrees, that's another concept. What is the degree? That's the highest power of x in the numerator and the highest power of x in the denominator. So what is the degree of px? So this is px, the numerator is the px and the denominator is the qx. So what is the degree of px? It's 2. Let's write degree of px, that is 2. What is the degree of qx? That is also 2. The degree or the highest power of x. So what is degree of a polynomial? That's the highest power. Or any function, that's the highest power of x. We can see that here we have this equation 3x squared plus 5x, right? So this one could be written as x to the power 1, but that's not the highest power. The highest power is 2. So that is what defines the degree of the polynomial on the numerator, and that same thing could be applied for the denominator. For both of this, the degree is 2. Okay. Now, once you find out the degree, what you need to do in order to find out the asymptote or horizontal asymptote is compare the degree. And there are three specific cases. One case is when the degree of the polynomial or px or the numerator is greater than the degree of denominator. We have one definition. The second one, which is applicable to this case, which is where the degree of the numerator is equal to the degree of the denominator. So in this case, the degree of numerator is 2, degree of denominator is 2, so they are equal. There is the second definition of the horizontal asymptote of rational function. And then there is a third category when the degree of denominator is greater than the degree of numerator. So that will be the third case, and for that case, there is a different definition. Okay. Now we know, at least for this case, the second case where we have this degrees are equal, right? Degree is equal to 2. If that is the case, then the definition of the horizontal asymptote is given by the ratio of the coefficient of the highest degree. And what I mean by that is, if you look into the numerator, this is the highest degree and the coefficient associated with the highest degree is 3. If you look into the denominator, this is the highest degree, right? But the coefficient associated with this is 1, right? So we take simply the ratio of the coefficient, and that gives us the definition of the horizontal asymptote for this specific case. When the degrees of the polynomial in the numerator and the polynomial in the denominator of the rational functions are same, right? So this will be one thing that we need to know. And again, this might not be a concept that you have come across. This is a definition. Given a rational function, what is its horizontal asymptote? There are three cases, and for each case we have one formula, and you need to remember that, right? So again, you might not have come across at all this one, but this is why we need to practice and remember all of this, and we will create a system of remembering all of these problems. Okay, so let me stop this, but see, we'll go through the approach again, revise the approach again. Degree of numerator first, which is 2, degree of denominator, which is 2. When the degrees are equal, the horizontal asymptote is the ratio of the leading coefficient. So what are the leading coefficient? This 3 is the leading coefficient of the highest x power. In the numerator, 1 is the leading coefficient of the highest x power in the denominator. So the ratio is going to be 3:1, and y equal to 3 is going to be the horizontal asymptote for that specific case. So again, this is going to be the answer.